In this video, we're going to prove the following theorem. We're going to prove that the eigenvalues of A are the roots of the characteristic polynomial of A. Remember that the eigenvalues of A are the lambdas that have certain property. So the proof will start off with this, as this. Let lambda be an eigenvalue of A. We want to show that lambda is a root of the characteristic polynomial. Now, what does it mean that lambda is an eigenvalue of A? This means that there exists a vector x not equal to the 0 vector such that A times x is equal to lambda times x. But that's the same as lambda times ix, because identity times x is just x. But this is the same as lambda I times x. So we have this equaling that. Bringing this to the other side, we then have ax minus lambda I times x is equal to 0. Factoring out the x, we get this matrix times the non-zero vector x is equal to 0. Okay, so this equation has non-trivial solutions. Why would I say that? Because x is a solution and it's not the trivial solution. Trivial solution is x equals 0. Then this matrix, since that matrix times x equaling 0 has non-trivial solutions, then we know that the determinant of this matrix must be 0. Okay. Another name for A minus lambda I determinant equals 0 is their characteristic polynomial of A. It's not the characteristic polynomial for A. It's a characteristic polynomial of A for lambda. It's a characteristic polynomial. Now, one of the solutions to this, one of the solutions for that, including equals 0, is lambda. Lambda is a solution for A minus lambda I determinant equals 0. So lambda is a solution for this. But there's another name for that. It says it on this line right here. Another name for that is characteristic polynomial. Characteristic polynomial. Okay. Now, let's go in the reverse. Conversely, so what we want to do is say that If lambda is a root of the characteristic polynomial of A, then lambda is an eigenvalue. Conversely, let lambda be a solution to A minus lambda I equaling 0. But if that determinant is 0, then A minus lambda I times x is equal to 0 for some non-trivial x. For some non-trivial x. Say x is not 0. Okay, so what does this tell us? Well, distributing their x from this equation right here, we get ax minus lambda I times x is equal to 0. Bringing this to the other side, we get ax is equal to lambda I times x, but that equals to lambda times ix, which is lambda x. That is, ax equals lambda x. Oh, and x is not 0. So lambda is an eigenvalue for A, because A times x is equal to lambda times x. And that completes this video. This proof, I should say. If you just love watching theorems being proven, then it's a no-brainer for you to subscribe to my channel, because all I do on this channel is prove theorems. In fact, if in the comment section, if you left a theorem for me to prove, I'd make up a video proving it. That's not a problem. In fact, I like to read any comments that you like, especially ones that say how much you dislike my channel. I even read the ones that say how much you like my channel. Please tell your friends and family about my channel. Ask them to subscribe. You should subscribe yourself. And I hope to see you guys in the next video. Remember, watch and learn.